Hello everyone and welcome to today's Crush the MCAT lesson on the conversion table and fractions. Alright, so starting off with fractions, over here on the right I've written out the most common fractions and their decimal equivalents. You should know that 1 over 2 is equal to 0.5 and these are both considered a half. Similarly, 1 over 3 is equivalent to 0.33 and these are both considered a third. You should know that for the rest of these fractions too. When we multiply or divide fractions, we go straight across. So if we have 1 over 2 times 1 over 4, the 1's in the numerators make 1 on top, and 2 times 4 on the bottom makes 8. This makes sense intuitively, because we're multiplying two fractions that are both smaller than 1 together, and our product is going to be a number that is smaller than either of those two fractions. Similarly, if we were to divide these fractions, let's say 1 over 8 divided by 1 over 4, we get a 1 on top, and 8 divided by 4, we get a 2 on the bottom. Again, this intuitively makes sense because we're dividing 1/8 by a number smaller than 1. So our product is going to be bigger than 1 over 8. It's important you use your intuition when you're working with fractions, and you should always be asking yourself, does my answer make sense? You can multiply or divide by any equivalent of 1 to find equivalent fractions. We're going to use this in a second. And when you add or subtract fractions, you need to have the same denominator. For instance, if we have a quarter minus a 16th, we need to convert this. And we do so by multiplying 1 over 4 by 4 over 4, which is just an equivalent of 1. And we're going to get 4 over 16 minus 1 over 16. Now we can successfully subtract these, and we get our final answer, 3 over 16. Alright, let's do some more practice with fractions. Over here we have 5 times 2 in the numerator for 10, and 6 times 3 in the denominator for 18. We get our answer of 10/18, but this is not our final answer, because we can simplify this fraction. If we divide the top and the bottom by 2 over 2, we get 10 divided by 2 is 5, and 18 divided by 2 is 9. For this next one, it's addition, so the denominators need to match. We can switch it to 4/12 plus multiply by 3 over 3 for 3/4. 3 times 3 is 9, 3 times 4 is 12, and we get our final answer of 13 over 12, which we're going to keep in fraction form. For this next one, 2/5 plus 1/2, we can't make either denominator match the other, so we need to turn both into tenths. So we get 4/10 plus 5/10 for our final answer of 9 over 10. Alright, let's talk about the conversion table now. So this is a long table combining all of the multiplication and division in a question. It's basically a mega fraction. The point of this is to make everything you do easier. It helps you understand when you should divide or multiply. It allows all your work to stay together, and it makes all of your work super easy to check. It also, very importantly, allows you to cancel out numbers and units too. MCAT math always involves canceling out numbers or simplifying numbers, so this is a crucial skill to develop early. Let me show you an example of a conversion table now. So, Alex is at the farmer's market and he has 200 apples and he wants to convert his apples into pomegranates. We're going to start with 200 apples on the left, and on the right we're going to write out our final unit of P for pomegranate. Now, the conversion table again is like a mega fraction. So what we're doing is we're going to multiply all of the numbers on the top together, and then we're going to multiply all of the numbers on the bottom together. Eventually, we'll divide the numerator by the denominator. So the first thing we need to do is to write out all of our conversions. The first conversion we're going to write out is 5 apples for 3 oranges. Notice that I've put the apples on the bottom, and I knew to put them on the bottom because we want to divide out the apples unit. So because apples is in the numerator here, and in the denominator in this cell, we can cancel out both of the apples. Now we know we've successfully converted apples to oranges. We're going to keep doing that for the rest of the units too. 4 oranges for 12 lemons, 6 lemons for 1 melon, and 2 melons for 1 pomegranate. Now, let's check that we did everything correctly by making sure our units were set up correctly. We can cancel out the O's and the L's, we can cancel out the M's, and we're left with our last and final unit of P for pomegranate, so we know that we've set up everything correctly. Next up, before we do any math, I want to make sure we simplify this table so we do the least amount of work possible. Notice on the top we have 12, and on the bottom we have 6 and 2. We can combine this 6 and 2 to make 12, and then we can cancel out the 12 on the bottom with the 12 on the top. Anytime we cancel out a number, we're just left with 1, which I'll write this time. Now the only numbers we have left on the bottom are 5 and 4, which we can combine to make 20. This 20 can cancel out with the 200, so that we're left with 10. Now the only math we have left to do in this problem is very easy, despite there being a lot of conversions here. All we have left to do is 10 times 3 to get our final answer of 30 pomegranates. Now, let's use a conversion table with a real AAMC question. So this question has us starting off with 5 liters of blood, and we want to convert these 5 liters of blood into kilograms. So we're going to set up our table starting off with liters and ending with kilograms. Now the first conversion we have is converting liters into centimeters cubed. I'm going to put liters on the bottom so the units cancel out, and I'm going to put centimeters on top. The next thing we need to do, because we're given density in kilograms per meters cubed, is convert centimeters into meters. 1 meter contains 100 centimeters, and in order to get this into cubic meters, we need to cube all of the numbers in the numerator and the denominator too. Now, instead of working with 100 cubed, I want to turn this into scientific notation, which we can do by turning 100 into 10 squared and cubing that. Whenever you cube scientific notation, you just multiply those two exponents together. So we get 10 to the 6th. So I'm going to change this 100 cubed into 10 to the 6th centimeters cubed. Next up, we have our density. So we're going to convert meters cubed into kilograms. We write 1,060 kilograms and 1 meter cubed. Now let's check that we set up everything correctly by canceling out our units. The liters will cancel out. The centimeters cubed will cancel out, and the meters cubed will cancel out too. We're left with our final unit of kilograms. Now we need to simplify the numbers in this table. So I want to change 1,000 into scientific notation. I want to change that into 10 to the power of 3. And I want to simplify this 1,060 into 1,000. Remember, MCAT math always involves simplifying, and if we take a look at our answer choices to be sure, the base unit in A is 2 kilograms, for B and C it's 5, and for D it's 10. So we know that dropping 60 from 1,000 isn't going to change our answer. And then I want to further simplify this 1,000 into 10 to the 3rd. So notice that we have 10 to the 6th on the bottom, and we have 10 to the 3rd and 10 to the 3rd on top. We can cancel out all of these numbers because when you multiply 10 to the 3rd by 10 to the 3rd, you're just adding the exponents together and getting 10 to the 6th. So we can cancel all of these numbers out. Now the only number we're left with here is 5, and that means our final answer is going to be 5 kilograms, which is answer choice C. And that concludes our lesson on the conversion table and fractions.